Han is not here. Who's the other one that's not here? Wei Xiang. Wei Xiang is sick. Can someone help me find Han? Anyone? Help me look for her. Bring her back. Someone to go with you. Your phone. Yeah, let me check. If you're okay, you can try 1.3. Yeah. Not this year. Next year. Next year. You want to know? You want to know the formula? Have. If you are in 8, you might be able. Where's Xuan? Try to find.
I don't know. Sorry, I just said the. Huh? I didn't see her.
But if you know how are you in A? Your game. Use implicit differentiation. Cannot you let y equals sine inverse x, then you find y equals to x. You try from here. Cannot. I don't show you too much, but it's can confuse everyone. But you can figure it out. Try prove to me. You can prove to me, I give you a price. The price is you get to see your doctors for 1 week. Okay. Why? Why? You like her? That's only wrong. Is it? Did I accidentally say something? Joking only. Is it? He like you? Is it? Sorry. Okay. Because he sit beside you then. Okay. Why you like doctors? Oh, there was romances OBS. I don't know. Sorry. I didn't mean to say anything insensitive. Okay. Looks like I hit some nails on the head. Oh, okay. Are you all going well? No. Let me show you the first one. Okay, so first one. Oh, okay. Okay, sure. Okay, now just think of this as U and think of this as V, right? So if you write U here as 1, b as sine x, you will know that u prime will be 0, b prime will be cosine. So the derivative of 1 over sine basically is differentiate u prime 0 multiply by sine x, subtract 1 multiply by cosine over sine square. What does that give you? It gives you negative cosine over sine square. What is cosine over negative sine square? 1. 1. Okay, what would this be? I split this up. Okay, into 2 fractions. What is cosine over sine? Cotangent. What is 1 over sine? Cosecant. There you go. Easy peasy, lemon squeezy. Okay, can. Stop looking outside. Can Then I go to part 2. Again, you use the same idea. You just need to change everybody. Use quotient rule. Okay, you can actually use chain rule if you know how, but let's talk about this later. All right. Okay, stay with me. Don't get too distracted. What is u prime? 0. What is v prime? Negative sign. Okay. So you can see that with these 2 new friends, you can conquer many places. You can actually derive and differentiate many new functions, which is so beautiful. Oh? Yeah. So you go back home, you can write this on your study table. It's very beautiful formulas. Okay. And so if all is good, I'm going to show you here as well. Question 1.2. Okay. Yeah. You differentiate. Differentiate tangent against the square. Okay, so let me just write it here. Differentiate tangent is actually secant square. And here, just try to memorize that. Here. Generally, when I first use these guys, I actually put them on my file. Okay. Second, differentiate cosecant, differentiate cotangent minus cosecant square minus cosecant cotangent. And this is secant x tangent. One of the things that I want to say is anything with a pole. See anything with a pole. When you differentiate, there's always a minus sign. You realize? Always got minus sign. Okay, differentiate secant tangent, right? See, if from secant I add a pole, then here also I add a pole, here also I add a pole. A minus sign. Differentiate tangent is secant square. But if I add a pole here, cotangent, cosecant square minus. Okay, so with that, you have 6 formulas. Okay. If you're okay, I notice that many of you are already at 1.3. Yes. Thank you. Okay, thanks for communicating. Okay, so here, from the last step to the second last step to the last step, right? Okay. Now here and here I can solve. Right. Then after that, 1 over sine square. Remember the third letter, sine is 1 over sine is cosecant. Okay. Okay. Are you all going smooth with question 1.3? Sorry? 1.3b. I'll get that. Give me a second. Let me just explain that. 1.3b, the answer is negative 2x sine x plus 2 cos x. Okay, so next I will go on. Okay, 1.3. Are you all trying 1.3 already? Remember that trigo function, they still follow your product rule, quotient rule, chain rule. I will talk about chain rule later. Okay, when you all do. Yeah. Okay, ma'am. Okay, so okay, very good. Some of you are already there. So I'm going to show you 1.3. Okay, please take a look and check your answer. I'm going to write the answers in red at the side. Answers in the fraction 1.3 A. P minus cosecant x cotangent x b minus 2x sin x plus 2 cos x c x secant square x minus s square over x squared. Okay. Okay, okay, so next I will go on to, you just hear me out, I will talk about the chain rule. Okay, chain rule. Okay, chain rule is a little, it can be confusing. So if you don't mind, just hear me out. Okay, give me 1 minute of your time, even if you have learned it before. Now, remember the chain rule where I explained chain rule, what was the analogy? I go from where to where? Big to small, from outside to inside. Remember? So I always go from outside to inside. So for example, last time, when I asked you to differentiate something to the power of 5, say 6x plus 7 to the power of 5. Okay, then what do I differentiate first? What do I look for? I look for the, where's the outer function? Remember not? We try to see outer function. We try to see inner function, correct? Then what was the main idea? Differentiate outer times differentiate inner, huh? So same. Remember the idea was to differentiate outer, differentiate power 5, which is the outer. Chain. The chain is the multiplication sign. I differentiate inner, which is the 6x plus 7. Okay? Now, same idea. What do I get when I differentiate sine x? Cosine x. Differentiate sine of 6x plus 7.
So who is the outer now? This is the outer. Okay? This is the outer. Okay, this is the outer. Can you see? This is like the enclosure outside. Who is the inner? 6x plus 7. I just share with you how I do it. Okay, maybe you have many ways. ChatGPT might tell you another way. So I go from outer to inner. Okay, outer layer is sine. When I differentiate sine, so I differentiate sine of something. Multiply, I differentiate of 6x plus 7. Okay, this is layer 1. This is layer 2. Okay, differentiate sine, what do I get? Cosine. So I differentiate sine layer 1, I get cosine. Differentiate 6x plus 7, 6. What's my answer? 6 cosine. Bracket. Whatever is inside, I just copy paste. Copy paste. Copy paste. Copy paste. You can't expect. The answer. Or you take your addition. Okay, so far okay? Okay. Joshua, differentiate sine 2x. Ethan Tong, differentiate sine 3x. Ophelia still okay. Jason Lloyd, differentiate tangent 2x. Tangent 2x. 2 secant square? 2 secant square x. 2 secant square 2x. Correct. Locus. Differentiate cosine 5x. Differentiate cosine 5x. Correct. Mitra, differentiate cosine 4x. Cosine 4x. Okay, good. Timothy, differentiate secant square to e power x. Okay, just kidding. Haven't teach it. Okay, Timothy, differentiate tangent 7x. 7 secant square 7. Okay. Okay, you all understood well. Very good. Okay. So, okay, let's try question 1.4. Can all guys? So, whatever is inside, you just differentiate to outside. That's all. Okay, so it applies for everybody. Okay, here, Jaden Lloyd, Joshua. It applies for everybody. Yeah? It applies for everybody. Okay, it's not just for sine. Okay, huh? Don't need to. Unless the question says something that to express in terms of sine, cosine. Okay? Okay. So now as you do, okay, now you just try, do all the way 1.4, 1.4. Okay. Is there anyone already at 1.5? Okay, so if you those who are at 1.5, may I have your attention? Okay, so differentiation of trigo is not easy, It's not easy, Are you all stuck or are you all going well? Okay, let me go through, Okay, so now trigo, right? I'm going to introduce the second type of chain rule. Okay, can Javier, Jukai? The second type looks like this. Okay, so far, if I give you something like this, Javier and Jukai can do, right? Okay, so now can I introduce to you Javier, Jukai, Timothy, Mitra? What if I do this? Power 4. Difficult, huh? Difficult, huh? Okay, so what do I do? This power 4, Can I say that is this? Can I say that is this? Yes, yes. But you're doing chain rule 2 times here. So how many layers do you see? The first layer, blue. The second layer, brown. The third layer, red. Okay, so first layer, layer 1 is that something to the power of 4. Layer 2 is sine power something. That's layer 2. Layer 3 is over here. 7x plus 6. Okay, so if I differentiate sine 4, 7x plus 6, I write it this way. This is like me differentiating sine 7x plus 6, the entire to the power of 4. Okay, this will be differentiate layer 1 times differentiate layer 2 times differentiate 7x plus 6. Okay, I hope you all can see. Now the answer will just be what? 4 something power 3 times sine 7x plus 6 times 7. So this is 4 sine 7x plus 6. Okay. Whenever I see constant 4 and 7, I will put them together. This is 28. Hey, sorry, wrong. This differentiate sign is not sine. Differentiate sign is cosine. This teacher are horrible. Okay, so multiply by sine. Now you can bring back the 3. 7x plus 6. Is it okay? Can I? So when there are Yong Kai, put my low then.
Oi, okay.
Okay. Can I? So if you have C layers here, remember if there's a power 4, look at the power 4 as the first layer. Look at the power as the first layer. Look at the trigo as the second layer. Look at the 7x plus 6 the third layer. Okay? Okay. This is to prep you for question 1.5. This is to prep you for question 1.5. Okay? Okay. I am going to explain it again because I think some of you may not have taught it the first time. Yeah. So even if you don't want to pay attention, okay, because you might have studied the first time. So if I differentiate, sometimes I may differentiate something like this, sine, then I have a power 4, I have a 7x plus 6. Where did I come from? 7x plus 6. Okay. And so you can see 3 colors. Because I want to show you that there are 3 layers. I write it this way. This is the same as sine 7x plus 6. Okay. Layer 1 is red, layer 2 is blue, layer 3 is orange. So you differentiate layer by layer. Okay. 4 power something 3. Differentiate layer 2, cosine power something. Differentiate layer 3, 7. Okay, Hop. And anyone need me to go through again? I'm happy to do so. I will write down the answers to question 1.5. Yes. So secant square over tangent, right? Secant square over tangent. Secant square over tangent. Tangent of tangent square. Just square. So you change this. You change this to 1 over. Okay. 1 over cosine square is the top, right? Divided by sine square over cos square. Correct? Cancel. This is just 1 over sine. 1 over sine square is just minus. It's just cosecant.
may have a minus sign somewhere. And all.
So if you're okay with this, I will show you question 1.4. I will write the answer on the board. Okay. Answers are on the right side. Answers are on the right. Question 1.4. Answers are here. Very, very easy and nice. Question 1.5. Don't worry, it's all worked out by a certain formula. Okay. Yeah. Huh? Part C. Okay, give me a second. Part C, which one? 1.4. Because when you differentiate cotangent, it's minus cosecant square. So when you differentiate cotangent, right? When you differentiate. Huh? Oh, okay. Okay. I thought I go toilet inside. Okay. When you differentiate cotangent, right? Can I say it's the same as this? By right, it should give you minus cosecant square, right? Square. Then differentiate chain rule inside. Differentiate blue color layer. Alamak, they all look the same. I'm colorblind, sorry. Differentiate brown, then you differentiate green. Differentiate brown, already you get this one. Differentiate green, you get 3x power minus 3x power minus 2. Right, power. So the 2 minus sign will cancel out. Right, there are 2 minus sign here which will cancel out. So you get 3 cosecant square 3 over x over x squared. Did I get it correct?
You read it a non-fraction like 3x to the power negative.
Yeah, it's fine. It's fine. Okay, yeah. Yeah. Brayden? So, Zoe? Yeah? Yeah, how do I do? 1.5. Which question? The first one. 1.5a. Okay, so 1.5a, before you do 1. You catch my explanation about the chain rule for second layer? Okay, so I'll explain it again. So for Trigo, right, there are 2 different types of chain rule. Okay, actually got 3. Okay, so many layers. Okay, so the first one, you know, is something like this, right? Okay, then I believe Zoe can see that. Ayo, where should I be? Oh, where should I be? Okay, like that can? Okay, so this is sine 7x plus 5. Okay, who was I explaining to? I forgot. Can you see layer 1, layer 2? Okay, but let's say I add a third one, red color, 8, 4. Can I say that this is the second layer, third layer? So how I do this also? You remember the idea of chain rule is differentiate from outside to inside. Can I? Just like I peel an onion. You peel an onion, or peel a durian, what happens? Peel and peel and peel, right? So I look at this like sine 7x plus 5 to the power of 4. Can you see this? This is so beautiful. Power 4 is the first layer. Sine is the second layer. 7x plus 5 is the third layer. So I differentiate layer by layer. So Zoe can see that here, right? Layer 1 is something power 4. Layer 2 is sine of something. Layer 3 is 7x plus 5. When I differentiate layer 1, 4 something power 3. When I differentiate sine, I get cosine. When I differentiate 7x, I get 7. All you got to do, multiply all this together, you are done. Okay, all? Yeah, can I? So I think this is very easy. I think this is more than enough for you to solve 1.5a. Okay, so for 1.5a, all you need to do is to see as sine x power 2. I think you will know what to do. Okay, can I? 1.5 answer is on the board. Now I go to 1. Yeah, 1.6 also. Okay, 1.6, 1.7. Anybody at 1.7 already? I hope not so fast. You seriously what is you done? Okay. Wait, you're so fast I cannot catch up. 1.6. 1.6a, 4 tangent x secant. 1.6b. 1.7. If you can reach 1.7 by this, it's very good. Yes. Okay, I'll go right. Okay. So I go through again. Go through. Oh, you okay? Yeah. So I just go through one time. Just to double, triple confirm. So I'm going to go through question 1.5. So here I write it this way. Red color, cosecant 1 minus 5x, blue color power 7. Brown color. This is what it looks like also. And the different layers are different colors. Can you see? Layer 1, if I differentiate, sit down, power 2, right? So if I differentiate, I get 2 power something 1. Layer 2 is cosecant. Cosecant, whatever that's inside, if I differentiate, I get minus cosecant bracket, cotangent bracket. Layer 3, something power 7, I differentiate 7 something power 6. Layer 4, 1 minus 5x, I differentiate, I get negative 5. Sine square x. Sine square x. Okay, sine square x, right? Okay, you can see. No, here, are you doing sine of x power 7? Or are you doing sine 7 power x? There's a difference. This is the entire sine x power 7. You understand? That's the one that you have to. Okay, One is a sine of a power function, one is a power of a sine. Yeah, that's what I want you to be confused about. Okay, so you need to think. Okay. So the layers make a difference. The layers make a difference. Okay, all. Here. Is 1.5 okay for everyone? Do I need to go through? Clear. Any problem? Normal differentiation. Normal equation. 1.7. I go through 1.7. Okay. Can. So let me write out this one first. Okay, basically, guys, if you have a sine of n power x, you can see that you differentiate outer layer, differentiate inner layer, this is what you get. Okay, you differentiate sine power n, fx again, you see the outer layer, inner layer, that's what you get. Okay, and you're just, if you're okay, can you look at page 8 and can you copy this down? Okay. So in later, I send you all the teacher notes. Don't worry. So if you're okay, you copy this down. This is at the bottom of page 8. That time I sent you a baby photo, do you see? You never see. You never reply me. Did you reply me? Never reply me. Okay. Yes. Channel. This is at the bottom of page 8. The idea is basically the same. It's just to tell you that, guys, when you look at sine n power x, this is sine n power x is sine x, the entire to the power of n. You must try to see this as an outer layer. Okay? It's because in Trigo, it's a little confusing, right? Like that's how you see Zoe and I were like discussing back and forth. Okay, so when you talk about sine, for example, sine n to the power x is not the same as sine of xn. They are different. This is a sine of a power function. This is a sine of function power x. Okay, they are different. Stop copying. Copy already, no? Copy already. What are you doing? Are you copying? If I find out that you haven't copied and you are doing your revision package, I'm going to take you. Why you never copy? I will punish you now. Okay, good. I punish you, sit beside doctors for a week. Okay. 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 So yeah. Can Okay. Just remember got chain rule. The idea of chain rule doesn't change. Even if you see this in your quiz next week, the idea of chain rule is always differentiate from outside to inside. Yeah. So I hope you are okay. Yeah. But if you do 1.7, 1.7 will also help you to revise your okay.
不是说没有投入，我还是在投入，只是我投入的正确。因为这个其实没有，原来是一种还是一种反正会包括这样
Okay, quick pause. Okay, guys. Last 5 minutes of the lesson. Without practice of write down the picture, double angle, R formula. Okay. Write down. Even if you have done it somewhere 1,000 times already on yeah. So addition, formula, R formula, double angle formula. I know it's not healthy, but no choice Pythagorean. Write down these 4. Pythagorean identity. Try and try. Every day I do it. Every day I do it. It's muscle memory. Trust me. Okay, it will pay you well